The way math is being taught is based on only one brain quadrant as per my four brain learning approach. The focus is to tell the children about some definitions and rules and then provide them the formula. Therefrom, as a natural conclusion of this initial setup of data in the student's brain, they are taught how to solve problems using those rules, definitions, and formulas. Once they are clear about these instructions of how to solve a particular type of problem, they are made to do the same task without any kind of clue. Sometimes the problems are altered minutely by just changing a value of certain numbers. Sometimes the question is twisted so as to confuse the student. Then, once the student is able to solve problems from that chapter on his own, even though they were designed to confuse, then the educational system qualifies him as having completed a particular grade. In the next grade, the process repeats itself. For some PhD students in pure mathematics, it goes on for dozens of repeats. For the average student, the above cycle of being taught the rules, then made to solve problems using those rules ends when they reach grade 12. The assumption of this teaching approach is that the student will be able to pass or score an A by activating the lower left brain or the skill quadrant in my four brain learning model. The truth is that it really works. However, the hidden assumption is that the student has got a natural wiring in that particular skill brain quadrant that enables him to follow that earlier learning cycle and consequently develop math acumen. However, most students do not have such wiring, and their brain, or should I say the lower left brain or the scale quadrant, is not that malleable. What happens is that the student doesn't get some of the rules or the definitions or the classifications or the formulas. Consequently, he cannot solve a simple problem because he doesn't understand the progression of steps from the beginning of the problem to the final solution. Since mathematics is always dependent on the earlier understanding of concepts to understand the later concepts, the average student finds himself missing so much data. This prevents him to complete several steps in the solution of problems. This leads to the wrong answer, then the student becomes unsuccessful. This leads to demotivation. Then the student becomes negative towards mathematics. He develops the concept that he's not made for mathematics, or worse, he is not smart, or still worse, he is dumb. As you can see in the diagram, I have shown a table and its corresponding star graph. I have tried to illustrate the above point by broadly categorizing mathematical studies into traditional and modern. The above process is obviously the traditional approach. As per the table, you can see that of the total score of 7, the traditional approach is highly focused on the skill brain quadrant. We can say it is fully dependent on it and the cycle of simply learning the rules and solving problems using them. As you can see, there is very little focus on information and knowledge. It exists in the form of difficult questions, as the students call them. Those questions try to use real life situations. For example, a problem of trigonometry is phrased as find the height of a tower. In this way, even the traditional approach links to the information brain quadrant to some extent. Also, the problems in mathematics expect the student to have some skills that borders with the knowledge brain quadrant. You can find these questions occurring a lot in set theory. In this chapter, I have presented mathematics in the modern approach without going into the details because I will be doing so in the relevant section. I want to say that in the four brain learning approach, I have come up with a solution to the problem whereby the student misses certain rules that prevents him to solve certain problems in his later academic years. Even for the practitioners of the traditional approach, the concepts that I have brought for the skill brain quadrant will be revolutionary. You might ask why nobody came up with what I have presented in this chapter. Well, it's because nobody started from the four brain learning approach. Everybody started and stayed in the single left lower brain quadrant or skill brain quadrant. This is why I have given a score of 2 as opposed to 5 under the skill quadrant to signify that the right way to learn mathematics is not purely mastering the rules and being procedure oriented. Even if you miss out something, you can still be rescued, and that particular section will explore that. I have written an extensive section on trying to motivate the student to learn mathematics by expounding on the evolution and the history of mathematical realms or topics. In this way, it will be less intimidating for students. In the knowledge brain quadrant, I have basically answered what are the various brain muscles that mathematics develops. Also, I explore how to use those muscles in our day-to-day decision-making process, opinion formation, planning, and so on. Finally, I have added how we can bridge the math that we have learned at school and college into other disciplines, and even how to make math fun by using it in our relationships. In this way, this chapter is my attempt to bring a totally revolutionary, or should I say evolutionary, breakthrough in how math will be taught and can be learned. As you can see in this star diagram, the graphs are significantly different. So now let's begin our journey into the new modern approach of learning mathematics.